Okay, today we are going to be factoring trinomials, but this time let's make them a little bit harder, shall we? Let's go into a slight review of what you should already know. For one, a trinomial is a polynomial with an explicit amount of nomials, specifically 3. For tri, of course, means 3. So, poly, many nomials, tri, 3 nomials. And then, second, factoring is essentially reverse foiling. We know that this stands for first, outer, inner, and last. So just to show you a quick example of a FOIL, just take x plus 5, and let's do x plus 5 again. Now, we know, well, we have our first, and then we have, and that we know that is x squared. Then we have our outer, our x and our 5, so we have plus 5x. Then we have our inner, which is plus 5x again. And then we have our last, and we know that's 25. And so we'll answer, of course, x squared plus 10x plus 25. That's just a quick example of foiling. So foiling, we know that, but factoring is the reverse amount. So let's try a quick example of factoring. Well, we're given x squared, 6x, and 9. Well, let's get our binomial set up in the parentheses. So we know what times what to get x squared. Well, we know that's x. X times x is x squared. And then, well, these are both addition. So we can infer that they're most likely going to be adding. Then, what times what is 9, and what plus what is 6? Let's go over the factors of 9. Well, we have 1 and 9, and 3 and 3. 1 and 9 don't add up to 6, but 3 and 3 do. So we have x plus 3 multiplied by x plus 3. So when you have this part, always verify it by foiling out again. So we have x squared plus 3x plus 3x plus 9. And we know that 3x plus 3x is 6, and that's what we were given. So let's go over how factoring trinomials gets even harder, which is mainly what this lesson is going to be about. First, we have the coefficient. The coefficient is always in front of the variable, and usually we have a coefficient in front of the second term, like right here, but very rarely do we have it in front of the first term, in front of the x squared. This makes finding this second term a lot more difficult. Then second, we have, when you have an extra x in each term, you're going to need to factor out that x. You're going to need to bring this x out in front before you actually do the factoring, because you can't factor all of this, but you can factor the inside right there. So let's move on to some examples. First, we're given 3x squared plus 18x plus 27. Well, let's start off with our binomials, our parentheses. Okay, we know that there's going to be an x. We know that there's going to be addition. That's what we know for sure. Why? Because there's addition sign, and x times x is equal to x squared. However, now we have this coefficient. Now where will that coefficient go and how will it lead? Well, let's go over the factors of 3. Well, they're only 1 and 3. So just for show, let's put the 1 there and the 3 there. So we know that's going to give us 3x squared. Second, see, we know we're supposed to ask ourselves, what plus what gives us 18? Well, that becomes trickier because of the 3. Because we don't know how everything is going to turn out when we FOIL it back out. So let's go over the factors of 27 because we know that will most likely work. We know that the factors of 27 are 1 and 27, 9 and 3. 1 and 27, that's probably not going to work. So let's try 9 and 3. Let's see if 9 and 3 can get us the answer we want. Let's put a 9 there and a 3 there. Now, it could be in a different order, and let's check that out. Okay, first times first, we have the 3x squared already. Then we have 9x. And we have 9x again. And then finally, we have our 27. Well, we know that 9x plus 9x is 18x, so we have our answer as originally shown. So we factored this with the coefficient correctly. Let's move on to a different example now. Now this one's going to be a bit trickier because it has such large numbers as you see 50, 110, and 20, and that's a negative sign. So now we know that both are not always going to be negative, but this one's a positive. So if one's negative and one's positive, what does that tell us? That they're both going to be negative. So let's start off with our binomials here. We know that they're both going to be negative. Okay, let's see. Now we have to go over, of course, all of our factors. What times what is going to give us 50x squared? Well, of course, we know we're going to have our 2 x's right there. But then, well, we can do 50 and 1. We can do 2 and 25. And we can do, of course, 5 and 10. Let's try 5 and 10. Next, of course, since this might be trickier, what times what gives us 20? Well, we have 1 and 20, 4 and 5, and 10 and 2. Well, 1 and 20 isn't likely to get us the 110. 4 and 5, maybe, but not necessarily. Let's try the 10 and the 2. Let's just put them in like we had right here. I don't know if this is going to work or not, but we'll see. So we have our 50x squared. We have 100x minus 100x minus 10x plus 20. Well, that, of course, is 50x squared minus 110x plus 20. We got lucky that time because you could check all these and that might not actually work. The 4 and 5 might have been something else. So there's multiple ways to do it. But now that we went over those, let's go over to one last example, and I'll let Jared have this one.
Okay, so we already know how to factor out an x squared, but now we have an x cubed. So to do this, you have to factor out an x before you start doing the problem. So you factor out an x, and you're left with x squared plus 7x plus 12. Now we can set it up like any other problem. We got our x out there, and then we set up our binomials. Then we put our x's in here because it's an x squared. Now we need to find the factors of 12. The factors of 12 are 1 and 12, 3 and 4, and 2 and 6. Well, 1 and 12 doesn't add up to 7, so that's out of there. And 2 and 6 doesn't equal 7, so that's out of there. So we're going to use 3 and 4. So we have x plus 3 and x plus 4. Now, we're going to FOIL out the inside. So we have x squared plus 4x plus 3x plus 12. And then we still have that x out front. Now we distribute that x through, and it looks like we are going to get the right answer. Look at there, we did it right.
And these are how factoring trinomials can get just a little bit harder. Now, how about we have 3 problems for you to try out attached with this lesson, and try those out and see if you can try to factor trinomials harder. Thank you for listening, and that will be the end of the lesson.